Hey, welcome to the Makery, mainly for Alvin and Pujit. So the Makery is who we are. We are an org for you to learn about just like basically all the devices related stuff within computer science. So we have this semester is a little bit different from most semesters. This semester we have weekly meetings every Friday, and they are from 6:30 to 7:30. So like at this time. And it's just various workshops related to Arduino, Raspberry Pi, building other circuits, 3D printing even. So you can fill out that survey in the middle. It's tinyurl.com/gtmakery survey 2021. So in that one, you can join our mailing list, and then we're also asking you to put in a couple like workshop ideas that you want to learn about. On usual semesters, we also have these larger projects where everyone can get together and apply what they learned in the workshops to a larger project. So one of our projects right now is building a go-kart out of Lime scooters. So Lime, they had a couple scooters that don't work anymore. So they gave us the motors from those scooters, and now we're using those to create a go-kart. I unfortunately can't really show you that right now since we don't have a mobile camera, but next meeting we should have mobile camera set up to show you guys the car. Okay. So, yes. Okay, so this is one of the Lime scooter motors that we got. So you can see it has a bunch of random wires that come out. So we researched the Lime scooter motors and we've figured out what each of these wires is doing, and then we're using that to control these motors with something called an O drive. And yes, more on that can come later. Okay, so Tinkercad is what you can use if you don't have an Arduino at home. So Alvin or Pujit, do you guys have Arduinos with you, or do you not have any of this stuff? You can just drop it in the chat if you don't want to unmute. Sure. Nope. Okay. Yeah. So that's what we assumed. A lot of people probably won't have Arduino hardware at their houses. So we encourage you to make an account on Tinkercad. You can just yes, you can go to that tiny URL, or you can just Google Tinkercad, and it's probably going to be the first result. You can sign up there and make an account, and that way you can virtually follow along with all of the workshop stuff that we work on. Okay, now I will move on and... Okay, so let's get started with learning how a button works. Okay, yeah. So the way a button works is I can just mouse. Okay, so let's open this Tinkercad file to show you how a button works. So we'll release these slides later, and you will be able to open this Tinker, and you can create a copy of it and like work on it yourself to kind of play around with how things work. Here's chat messages.
Yeah.
Okay.
It does have, if you go to like the 3D modeling thing, it's kind of like an online version of like SolidWorks or Inventor, but it's kind of like really crappy because it runs in a browser. So you're better off using like an actual desktop software or like Fusion 360 or something like
that. Okay. So hopefully this loads. Yeah, so whenever you open one of these like Tinkercad links, they have a nice little thing to just simulate it without having to duplicate it if all you want to do is look at how it's working. And unfortunately, it is not loading. Okay, there we go. So this is our circuit. So we have our ground connected to the minus rail. Oh, so I can go over some of the Arduino basics since you guys weren't here yesterday.
last week.
Last week, sorry. So I can switch this view so you guys can see what I see. Okay. So you see this little, so this is called a breadboard. It's basically like what you can use to connect a bunch of different wires without like soldering and stuff. So you have a, can you autofocus the camera? Okay. So this is, it has two rails. Oh, that's very nice. Okay. I'm trying my best to keep this in frame. Working with a camera is very difficult. Okay. So we have this blue is a minus rail and this red is a positive rail. So then what you can do is you can connect the ground from your Arduino into rail. So if I get a wire and I plug it in from the, right here, you can see the 5-volt pin like right here. So I plug it into 5 volts, and then on the breadboard, I can plug this wire into the positive rail.
Yeah, the screen is lagging a little bit. I'm not entirely sure what we can do about that. Boy.
Okay, I'll try to stay still in the middle of the scene so you can see it. Okay, so you have the 5-volt plugged in on this side, and it's plugged into the positive rail here. So that makes this entire row of like holes is going to be the positive pin. So anything that you stick into this red rail and then somewhere else on the breadboard is going to be connected to 5 volts. And then we can do the same thing for the ground rail. So this is the ground pin of the Arduino. It's to the right of the 5-volt, and then we can plug it in to the minus of the Arduino. You see how this left side one is in this first row, and the right side is on the second row. So now we can plug in anything from the ground into somewhere else on the circuit. And then then this little section of 5 will be all connected. So the other thing about a breadboard, so we have these rails on each side of the breadboard, and then we also have these rows of 5. So like this little row of 5 is all connected, and then like this row of 5 is all connected. This row of 5 is all connected. Like this row of 5 is all connected. So you have a lot of different like connections that you can use to connect a lot of different things together. Does that make sense so far? I'll switch back to the button tutorials. Yes, makes sense. Amazing. Okay. Okay. Now we have the same thing on this circuit right here. We have this ground coming into the ground rail and this 5-volt pin coming into the power rail. And then we have a button right here and an LED right here. So if you watched last week's video, you'll recognize this circuit for the LED. But we basically just have the ground side of the ground rail is connected to the cathode of the LED, and then the anode of the LED is going through a resistor and then into a digital pin on the Arduino. So then using code, we can write a high voltage to this pin 12, and then it'll kind of complete a circuit because you have high, then it goes through a resistor, through the LED, and then into the ground of the Arduino. And then this button is hooked up to ground, and then the 5th digital pin. And now I will show you how this works. Okay. So I'll start with just showing you the simulation. So I can click the button and the LED turns on, and then I click the button and the LED turns off. Okay. Angela, I see that you just joined. Feel free to unmute with any questions. And yeah, just if you don't feel comfortable unmuting, just drop it in chat. Okay. Now, this is a little bit hard to look at the code and the simulation at the same time. I'll do my best for you guys. So please stop me if you get confused or if I'm going too fast or anything. So in the setup, we're setting pin 12, so the pin mode function is basically what we use to tell, it tells the Arduino that this pin is going to be used for this type of work. So pin 12 is being assigned output, and then pin 5 is being assigned input pull-up. And then this line it'll basically set up a serial monitor, and that allows us to like print out values and then also send values to the Arduino. That's basically like a debug console that we're creating by doing serial.begin at 9600. So I'll minimize this code. So let's remember 12 is output, 5 is input pull-up. So we can see that pin 12 is going to our LED because it was the output pin, and then pin 5 is input pull-up. And now I'll explain what input pull-up means. Okay. So input pull-up is basically we're going to use that pin as an input. So it's going to be it's like, yes, it is. So do you have a better explanation of
pull-up?
Yeah,
so
okay.
A pull-up resistor, what it does is it, go ahead and go to some view first. Okay, so you can see I have a breadboard right here, right? So here, if I have my positive rail, let's autofocus this. All right, are we good? We got resolution now? Yeah, okay. So if I have this, right here is my positive rail. And if I connected that to the button, well, let's connect it with a resistor. So let's take the positive, and we'll connect it to one pin for the button. And then the wire from that pin, this blue one, would go to the Arduino, right? And then this green one will go to ground. So what's happening here? Oh, there we go. Close. Okay, so what's happening here is the power goes through the resistor and to the Arduino. When I connect it, so when I push the button down, what happens is instead of going to the Arduino, it takes the path of least resistance and goes through the green wire to ground. So what that means is that the Arduino always receives a 1, and then when I press, or receives high voltage, when I press the button, it receives low voltage. Now, what this means is, what input pull-up means is that you eliminate this resistor, right? And you actually just, over on the receiving end at the Arduino, you have the resistor to power. So what that means is the Arduino will always receive power, and then when you press the button, it goes from the Arduino, it comes all the way back through the line and into the ground rail up here. So the input pull-up is just an easy way to cut a resistor out of the equation so that you can more easily design your circuit. Is that clear to everyone?
Okay. So yeah, so as we can see now, so when in the loop function, which for Arduino just runs over and over and over after the setup is run. Oh, let me switch the scene. Okay. Now you can see the code. So this loop function runs over and over, whereas the setup just runs once at the beginning. So in this loop function, we have digital read 5. So that's getting a digital reading, which is just high or low, from the pin 5, which is the input pull-up pin connected to our button. And if it's equal to low, which means that we've pushed this button so that, let me see if I can get this. No, I cannot. So you can see when we push this button, now the yellow wire is going straight, and then it connects here when it's pushed, so it goes straight into ground. So then it'll read the low voltage, which is coming from ground. So this logic right here is basically how we can turn a continuous high into like it runs once. So if we just had if digital read equals low, then and to switch the on state. So on equals 1 minus on is basically just toggling on from 0 to 1 and then from 1 back to 0. So if we just had it like if this is down, then switch it, then every time I press the button, it's just gonna rapidly switch back and forth. So by adding this check and not button down, so button down is basically was the button pressed in the previous loop. Because right here we set button down to is it pressed. So then when the loop comes back, this is like was it pressed in the previous run. So if it's down but wasn't pressed in the previous run, switch it. And now if like we hold it down, if we hold the button down, this loop is going to continue running, but button down is going to be true. So then it's not going to keep toggling the state. Does that make sense how we can use like this, like it saves the state of the button so that we don't like rapidly change the on value? Does that make sense to everyone, or should I spend a little bit more time explaining? Yeah. Okay, so why do we use low? So with the button, it's
because of input pull up.
Yeah, okay. So let's scroll up. Okay.
Not using it.
So when I click this button, so this yellow line is connected to port 5, and so that's this pin of the button, like right here. And then this other pin of the button is connected through this wire to the ground rail, which then goes to the ground of the Arduino. So which is, it's like a logical 0 or a low voltage. So then currently when the button isn't pressed, this wire isn't really connected to anything, so it's just a high. But then when we click this button, it completes that circuit. So now the voltage just escapes to the ground pin. So then it's just marked, it sees it as a low voltage because all the voltage is being just sucked into the ground essentially. Amazing. Okay. And then just here we have, if it's on, that write the pin to high, and if it's else, then write it to low. And right here, I'll show you this. So if we open our serial monitor, which is like our debug thing, so right here, we're printing button down, which is like, it's just the raw information of is the button pressed or not. And then on is like our state value, which is only going to toggle once when we press the button. So I'll probably have to zoom out for you to see this properly. Okay, can you guys still read the serial monitor? Okay, so if you see when I click this button, it switches the thing to 1, but then it goes back to 0, but this right side only just changed to 0. And I click it again, and this side stays at 1, but then the left side it went to 1 and then back to 0. Are you guys seeing how that's working? Yes. Okay. So now I'll move on to how we can use a potentiometer. Not full screen. Okay, so now we have a potentiometer. So the way a potentiometer works is it is an analog input that can take values that's like, rather than the button, which is just low and high, the analog inputs can be from 0 to 1023, which is like from low to high, but also everything in between. So we can use a potentiometer to accomplish that. Now, let's open this link. So now I'll just run the simulation before I show you guys the code. So you can see when I start the simulation, I'm not sure how clear it is on the video, but when the potentiometer is on the right, this LED turns on, and when it's on the left, the LED goes dark. I'm not sure how clear that is. Is that what's used for dimmers? Okay, so I'll answer Angela's question first. Why 1023? So 1023 is just a 10-bit number because 10 bits can store 1024 unique states, which is 2 to the 10th power. So it goes, but since we're including 0, it goes 0 to 1023, and that's just the standard of what it is. I don't have a very good answer for why it's not like a certain different power of 2. So is this what's used for dimmers? This is something that you can use for dimmers. I'm not sure if like the dimmers in like actual like house light would use like just a potentiometer. They might have like more complicated circuitry to make it like more safe or something or more consistent. But yeah, just a simple potentiometer you could use to create a dimmer. Now let's look at our code. So this code is relatively simple. We just set pin 6 to output, which is the pin our LED is connected to. And then we are also turning on our debug console. And then in the loop, we read in the value from the input pin. So you can see a potentiometer, the way a potentiometer works, it is a variable resistor. So that means depending on the angle of this little knob, it's changing the resistance that it provides. So we connect one side to ground, as you can see here, the other side to power, and then the middle one is going to pin A5. So it's like as we wipe around this circle, we're basically changing the amount of current flow that goes from power to ground versus power to this yellow wire. And that is what and then measuring that difference is what this side does on pin A5. And that gives us the value from 0 to 1023. So then we divide that power by 4 because to write, okay, so I should also explain Pwm pins. So this digital pin 6 is a Pwm pin, which basically means even though it's on the digital outputs, we use PWM, which is pulse width modulation, which is basically just like turn on and off at a rapid rate. So then rather than just sending a high, we can use the values from 0 to 255 to like emulate an analog signal, because so when we do like high, it's like sending an analog 255. So be on 255 out of 255 times. But then when we send like, if we analog write like 128, then it would be on half the time and off half the time. So when the potentiometer is about here, then it's doing that, like it's about half as bright. I know the LED is a little bit hard to see in Tinkercad. Once we move into the physical model, you'll see very clearly the brightness. So does anyone have questions about analog reading, writing potentiometers?
Yeah, Pujit asked.
I already answered.
Oh, you asked that? Okay.
Yeah, just please unmute or say questions if you have any. We really want you guys to learn everything about this. We don't want this to go over anyone's head. Okay, so now that we're all comfortable with using buttons and potentiometers, let's taste the rainbow with LEDs. So now we will make our little final demo for this tutorial or for this workshop. So it's going to use an Arduino and obviously the micro USB cable for it. And then a breadboard, an LED, a button and potentiometer, three resistors, and a bunch of wires. Okay, now let's switch to this view. Okay, so the first thing we always do is, I have a lot of wires. is we will connect our power and ground rails. We connect this guy from 5 volts, I guessed it correctly, 5 volts to power. And then we will connect this guy from ground to the minus rail. Can everyone see this? Sorry, I'm going way off screen. This is very hard. Okay, so once we have connected our 2 rails, now we will connect our RGB LED. So this is an RGB LED. Wait, let me do the makeup tutorial thing. This is an RGB LED. So it's an LED with 4 pins. So if you remember on the Tinkercad that I just showed you, the LED had just 1 pin and it was only red. The way this one works is it has that common ground, but then it has 1 pin for every color, RGB, and that allows us to make any color we want to. So I will just stick this in with each of the 4 color pins going into a different row of the breadboard. So you guys can see that? Yeah. And then we will connect each RGB pin to a digital pin on the Arduino. Yeah. Okay. So the other thing we need to keep in mind is we need to have a resistor between each of these little power points of the LED. Maybe this will be better for y'all to see. I will do my best.
There we go. Yep.
Yes. Okay. So we'll plug in. So you might be a little bit confused what I'm doing. So I'm plugging in this R. Or wait, actually, I think R is on this side.
R is all down the right.
So the longest pin of the Arduino was this.
Of the LED.
Oh my, I'm struggling, y'all. The longest pin of the LED was this 3rd one from the left. So that one will get a white wire because we don't have any black wires, and it will go to the ground rail. And then because LEDs are these small little boys, we have to put in a resistor before we send it to power. So we'll connect a resistor from each of the color pins of the LED to one of the other rows. You see that is flashing red because this Arduino has some old code that just flashed on and off. And then we take a resistor that goes from the green pin of the LED to this row of pins. And then another resistor. Can everyone see what I'm doing with the circuit? Is it all just like terrible and you can't see anything?
Awesome.
Yeah, okay, cool. Okay, so now I'll just move this wire around just to illustrate. That was red, and then if I put it in the row with green, you should see green starting to flash. That is not flashing. Wait. Okay, so blue is flashing. I think this LED might be broken because the green does not work. Let's use that LED. Okay. Yeah, so now you can see the green flashes when I plug this pin to the green side. So now I'll put this in the red, and we'll put in a green wire that goes from Pwm pin 10 to right here. And then this blue will go from 9 to here.
So Claren, hopefully I pronounced your name right. You just asked, why can't you just use one current limiting resistor between the LED ground pin and the ground rail? So Mudit just asked me this question earlier today too, because it doesn't really make a lot of sense, right? So let's grab a piece of paper and a pen, and you autofocus it to the level of the table.
Yeah. So yeah, Emmanuel's right to Angela's question. If you don't use resistors, then the Yeah, exactly what he said. The current is too much for the LED, and it'll like it'll fry the internal stuff of the LED, and then it won't work anymore, and then we become sad. So if you make a Tinkercad account, if you don't use a resistor in your circuit, you can go ahead and try. It'll show like a little flashy explosion thing over the LED because like you're not supposed to do that. Yes. And Kieran, my brother, will come back to answer your question. I will continue building the circuit. He's here with an explanation.
Okay, so how much time do we have? 20 minutes. Okay. So if we, let's see. So we have our LED. So the circuit element for an LED is so this is the element of the circuit element of an LED. This is our plus, or minus. Now, so the LED has restrictions. So generally, an LED has a restriction of operating with 20 milliamps of current, right? So if we have this stipulation and we're running 5 volts through it, right? So 5 volts, so we have our V equals I R, right? So 5 volts equals 0.02 times R. We get R equals, can you do this math for me, dude? Oh, R equals 250. Yeah? Yeah. So 250 ohms, so that's why here we've overestimated in our circuit, and we go ahead and use a 330 ohm resistor. So now, if we think about the diagram of what's going on, so if we have our plus and minus and our battery, right? So we're coming down. Right, so this is the diagram we have that comes out of the box if we didn't use any resistors, right? So here, if we have 5 volts and we want, well, really, we're sending a different voltage, right? So here we have 5 volts in, we have 5 volts in, we have 5 volts in, right? And we want it to output at full brightness. So if we put one resistor here, right? So the current is distributed equally across this. We have 60 milliamps going into this, which is going to take our resistance equals 250 over 3 equals 83 ohms, right? So we get 83 ohms that this resistor would be. Now, here's the problem is that the second I change, so say I want 2.5 volts, right? So if we got RGB, our 2.5 volts, we want the green to be dimmer. Now the current isn't distributed as well. So now this will get 2xi, this will get 1xi, and this will get 5xi. And we have this resistor here that we put at 83 ohms, which will mean that the current, because it's distributed equally though, we end up with too much current flowing through the green resistor. Or sorry, too much current flowing through the R and the B LEDs. So what happens there is then you risk blowing them out. But instead, if I drop the resistor here, then I know that I'm getting the correct amount of current through the LED at any given time. Does that make sense, Kieran? Now I'm going to go away with my ugly physics.
Hopefully that cleared it up. I will make sense. Great explanation. Amazing.
Yeah, you're welcome.
Okay. Now we will build up the circuit for our potentiometer and our button. So we have our button, and we put one side into the ground rail. Guys, sorry. And then the other side will hook up to our input pin 2. I'll go as fast as I can. I don't want to rush. This tutorial may go a little bit long, and I apologize about that. Okay, and now we will stick our potentiometer in, which you can see this little arrow. Let me autofocus your camera. Okay.
All right.
So this little arrow, I can rotate it like that. So like it works the same way as the little guy in Tinkercad did. So we'll put one side to power. One side to ground. And I know this circuit is starting to look really nasty, but yeah, I don't know. I have no excuse. It looks nasty. Most Arduino projects tend to start looking like this because you just have wires everywhere. Okay, and then I'm going from the center pin of the potentiometer. You see this little yellow wire, and then this will come around to analog input 0. So you can see right here. Oh my goodness, I'm trying my best. Yes. Okay, so it went into A5. So you can see the yellow is going into pin A5 right there. Okay, so now I believe that is our full circuit built. Now we will start coding. And if any of you come to the slides afterwards, we have this Tinkercad of this whole model built up with the code. You can open that on your own. And let me autofocus again for you guys. Okay. Now let's start coding. Open our code. And yeah, okay. Oh no. It needs to be smaller. Yeah. Okay. So in our setup, so we're using quite a few pins for this. We're using quite a few pins for this project. So what we'll do is we will create these things called define statements. So these are a tool that C has that you can do hashtag or pound define, and then you can type in some easy name to remember, and then what the value we want it to be. So if you see in this circuit, the pin 11 was this red one. So we have pound define red pin as 11. And the way that works is later on in our code, whenever we type in red pin in all caps, it'll just get replaced by the number 11. So it's not like a variable red pin equals 11. It's literally like we're defining something to just get replaced. The green pin is 10. Blue pin is at 9. Anyone please stop me if you have questions. Those are our output ones, and now let's define our input ones. So the button pin is 2, and our potentiometer pin is A5. Okay. Now, in our setup function, we'll set all of our pin modes for everything that we want. So I will try to be fast about this so you guys don't have to sit there watching and waiting. Oh wait, I can watch this, guys. I'm going to type real fast. Okay, so that is we're setting the pin modes for our red, green, and blue. We set button to input pull up. And then for the potentiometer, we don't actually have to set its pin mode, because if you look at the Arduino, I don't know if you can see it, but it says, oh, it's probably not unless I put autofocus, but right next to the labels for like the A0 through A5, it says input. So those pins are all just defaulted to input, so we don't need to set their pin mode. And then what we can do is just at the beginning, we'll just analog write. We'll just write all of our pins to 0. So let me type that out quickly. There we go. And now, so what do we want our code to do? So what we'll do is we'll set it up to where we can press a button and then we can change our red value, and then we'll press it again, change the green, press it again to change the blue. So that's just like a relatively simple example, but hopefully you guys can you can extrapolate based on using the button to store state and then the potentiometer to change something based on that state. So Emmanuel is asking, what does pull up mean? So we talked about this a little bit earlier in the video, so feel free to check the recording on that. I'll try to quickly explain it right now. So the way pull up, what input pull up does is, so the button is connected to ground here, and here it's connected to pin 2. So the Arduino is reading this as a high, which is it's the high. But then when the button is pressed, it connects the circuit going from pin 2 through the button and then through this white wire into the ground rail. So it's pulling it down to low. So it says input pull up, but in my opinion, it's a little bit confusing on the wording based on the actual functionality. But it's basically when you press this button, you'll be able to read the value as a low because it's connected to ground, so it's low. Apologies for the bad explanation. We had a little bit better of an explanation earlier in the video. Okay, so now let's create some variables to just hold our state. So we'll monitor which color we're editing. We'll store that button down variable how we did last time. And then we'll also just keep a reference to what our current potentiometer angle is. So we'll create these 3 variables. And then also in our setup, we want to put a default value for each of these. So we'll just set which color we're editing to 0, button down is 0, and then this analog read for the initial potentiometer angle. So what we'll do for which color is every time we press the button, we'll increment which color, but then the way we'll use this value is every time we press the button, it'll add 1, but we'll do modulus by 4. So if it's 0, we won't be editing a color, and then 1 will correspond to red, 2 for green, and 3 for blue. And then when you mod by 4, when we add 1 again, it'll go from 3 back to 0. Okay, and then let's also add our debug console to setup. So we'll begin the serial monitor, and this 9600 is the baud rate, which is the refresh rate of your serial. Not actually the refresh rate. It's complicated serial stuff that you don't really need to know if you're just using an Arduino to make stuff.
Is how many bits per second of data are sent? Yes,
what the smart one said. Okay. Now, after we've handled our button, and now this line will read the potentiometer angle. And then what this next line of code
will be mod 3.
So mod 3 will give you 0, 1, and 2, but we want a state where we're not editing the color. So then we'll have 0 be just you can turn the potentiometer without editing, and then the other 3 states will be Rgb. This is obviously just a very unique, not very necessary example, but it's just to explain the concept.
Emmanuel, if you're still interested in the definition of pull-up, after Mother finishes the tutorial, I've gone ahead and drawn out a diagram here so I can show it to you after we finish, if you're interested. And anybody else, if they want to see an actual diagram that kind of explains it a little better.
Okay, so now we need to determine if we need to edit one of our colors based on the value of which color. So the way C works is rather than having Booleans, for if conditions, we just check 0 or 1. So what we can just do is if which color. That means if which color is not equal to 0, which is exactly what we want. Only if which color is not 0 do we want to write to one of our pins. And then, so right here we'll do if which color equals 1, which means we want to write to the red pin, we'll do analog write to the red pin, and we'll do pot angle. Oh my, I can't spell. Oh my. Divided by 4. So, and this divided by 4, if you remember, is because analog reading, so analog sensors, they give you 0 to 1023. But when you analog write to one of your digital pins, those only go from 0 to 255. They have less granularity, so we have to just divide that number by 4, and then that perfectly scales the 0 to 1023 into 0 to 255. And then we want to just do this over and over. Oh no, I messed it up. Yeah. So then right here, and then we'll just make this an else if, and we'll do 2, and this will be green pin. I believe there's a chat message. No. Okay. And then here, if which is 3, we'll write to the blue pin. Okay. And now, so what we do is we go to, oh no, you guys cannot see this in the screen share.
What, the serial monitor?
No, this thing.
Oh.
So, I don't know if you get, so right here you can see this little tools thingy. So that's what you use to, like, there's a couple things in there so that you can use, one of those options is what you use to open the serial monitor, which is...
Go to OBS. All the way down on the left.
Right here.
Transition.
So right here, we have our serial monitor opened on the right. So that is where you'll see, like, if you remember from the Tinkercad where it was like 0 and 1, it was just like printing those values over and over. This little monitor is where we would see that value. So this program currently isn't printing anything, but let's just try to download it to our Arduino and see if we wrote good code.
I don't know which.
Okay. Now we can see it is done uploading. Now if we click this button, it should now go into the edit red value mode, and it works. So
go ahead and change the view a little bit.
Yes. Okay. And then let's autofocus the camera. So hopefully now you guys can see it. So then I can rotate this guy, and again, it's just the color is really blown out in the camera. It's hard to see it. But you can see like the bottom of the LED is a little bit red. I know the top just looks white. But if I can, whoa. If I rotate this, it's dimmer, and then off, and then as I come here, it gets brighter. Hopefully you guys can actually see it getting brighter now. And now it is better. So I'll click the button, and now I'm editing green. So now if I decrease the green, we see that it's maintaining just that red value from before, but I can slowly add green into the color. And now I'll try to get it even until it's a kind of yellow color. So now we have like a somewhat even mix of red and green. I know the color is extremely hard for you guys to see. And then now I've added blue, and it looks almost white, which is what we expect when you use the same value for red, green, and blue. Now I'll do this again, and I'll just turn off red, and then I'll turn off green.
You're not on screen.
Oh no. Okay. Now I can, so this is like I rotate and it turns green, and then I turn it off, and then I control blue, and then this one doesn't edit anything after blue, and then this one goes back to what? Seems like we have an error somewhere. In blue, red. Okay, so I might have made an issue with the code, but as you can see, we have those 4 states. So yeah, as you can see, even someone who's done this exact project 5 minutes ago, you can make mistakes. Okay, so now I'll go ahead and add in these little print statements, and that way we can actually use our serial monitor just to make sure things are going correctly. So let's switch our code to where you see our code. So I will come in here, and I will add some lines of code that just print out the which color. So which color is stored as a character, just because characters are only one byte of information, and we only need to store the values 0 through 3. So we're just being a little bit more efficient with our storage. But when we print it out, we want to see the integer value rather than the character value. And then we print out this little pipe just to separate, and this is our pot angle. And now let's download this code. And I see that it's 7:30, so thank you everyone for coming. Really enjoyed showing you all of this, but we will keep going for a couple more minutes just to finish off this tutorial. Okay, so can you guys read the serial monitor? Do you see that it says 0 and like 223 or something, or 230? Okay. Now, when I click the button, you can see that the left number changes to a 1, and we start editing the red. And then when the serial monitor is up to 1023, it's like a bright red. Again, I know the color's hard to see, but there's not much we can do that virtually. And then we'll turn the red back off, and you can see, and so now I click the button and again, and now you see the 2, and then I can make it green, and then back off. And then I click the button one more time, and now you should see the 3 on the left, and then the blue value comes up, and we can turn it back off. Yeah, this is just another short example of something you can do with buttons and potentiometers to control a simple LED. You could extend this to an entire LED strip. So neopixels are unique LED strips. They offer you addressability into each individual LED. We can do a tutorial on how to control those. But if you just have an LED strip that is the entire strip is always the same color, it has like an RGB pin, and you can do a similar thing to control that. So obviously you'll have to do your own research when you have your own LED strip light, look up the serial or product number, something like that, to see exactly how those pins work. But you can write similar Arduino code to do a similar thing for that as well. So that should wrap up our tutorial. Thank you everyone for coming. And so thank you everyone for coming. For those of you that need to leave now, just make sure you have filled out this workshop interest form, tinyurl.com/GTMakery survey 2021. Make this a little bit bigger. So tinyurl.com/GTMakery survey 2021. So that allows you to just put in some of the workshops you'd like to see later on. And then, as usual, we'll send out the PowerPoint so you can see all these links. And now I will give to my brother so he can show you what the reason is for input pull-up.
All right, so let's see. Let's get here. All right, so input pull-up, so what's going on in this diagram is I've drawn basically everything to the left of, everything to the left of this kind of like square, everything on this is on the Arduino, and everything to the right is on our circuit board. So here is our ground pin. So this is our ground rail that we've connected to one side of our button. So this right here is our button. And this is what's called a normally open button, meaning that the circuit is not normally connected. And it's a push button. So a short code for this is PB, so push button, normally open. So what that means is when the button is left alone, the current does not flow through. So now what we have is we have a wire from our button to the pin, the physical pin on the Arduino, right? So if we take this Arduino, right? Let's say we're using pin number 2. So this pin's right here. So this is the physical connection to the board, but this is not what goes into the actual sensors on the chip. So I'll talk about that in a second. So from here, so this is a point on the board that the wire touches. And what happens when we normally are connected, all that happens is this, where there's a sensor, there's like a voltage sensor on the receiving end, and it detects the line that comes in. So the problem with this is that when the button's not connected, you can see that the current flow or the current's connected to nothing, right? It's just floating over here. So what happens is that the value you read can be variable, it can be anything. But then when you connect it, the value would be 0. So this allows you to detect when it's connected, but not detect when it's disconnected. So it's not really reliable. So what doing input pull-up does is it adds this resistor that pulls the line up to 5 volts. So now that you think about it, you have this 5 volts coming down through the resistor and into the pin sensor, right? But this resistor does not consume enough voltage that it doesn't register as a high on the pin. So if we talk about a scale from 0 volts, let me write this in Sharpie, sorry. So if we go here, we got 0 volts and we got 5 volts, right? So there's actually like points in the middle. So if this could be somewhere around 2.5 and this could be somewhere around 3.5, right? And actually anything above 3.5 is high. Anything below 2.5 is low. Now the actual ranges differ slightly, but this is good enough for an explanation. So as I was saying, the 5 volts comes in and goes through to your pin sensor. So your pin sensor, when there's nothing connected here, reads 5 volts, so it reads high. Now, when I close the button, the path of least resistance is actually going all the way along the wire and through to ground because the pin sensor has some internal resistance. So what happens is then, when I close the circuit, the 5 volts goes down, goes through the resistor and becomes, say, 4.5 volts, and then it goes all the way over and goes to ground, and this pin sensor is also pulled to ground. So what happens is the pin sensor then reads low. So that's basically what the function and kind of how the input pull-up resistor works. Does that make sense?
Yeah, that makes a lot of sense. So the reason you have to have that resistor there is because if you were to just connect the 5 volts directly to, say, that wire, so instead of a resistor between 5 volts and that junction between the pin sensor and the button, if there were no resistor there, you would have a short circuit when you press the button, right?
Yeah, exactly. If you didn't have that resistor there, when you close the button, you would get way too much current flowing through and you would short circuit. Another problem is that there'd be too much current on this wire because there's 0 resistance, right? So the 5 volts would be attempting to give too much current, and then the pin sensor could fry. So the Arduino pins, they have a max tolerance, an input-output tolerance of about 20 milliamps. So you have to make sure that you're not feeding too much current in and that you're not asking too much current from it. Does that make sense?
Yeah, gotcha.
Like 20 to 40 milliamps.
Makes sense. Appreciate it.
Yeah, absolutely. Does anybody else have any questions they have about Arduinos or connecting LEDs and stuff like that? Anybody wants to, and they want to make a like LED strip controller for like a basic LED strip, I can talk through a little bit of the differences between the LED strip and the regular LED that we use today, if anybody's interested in that.
Sure, I'd be down.
Okay. All right, cool. All right, let me grab. All the way back. No. Okay, so the LED strip, well, we can talk a little bit about the LED strip and what it is. So we look at an LED strip, it's got what's called SMD 5050 RGB LEDs. So SMD stands for, so let's go SMD 5050. That stands for Surface Mount Device. And 50/50 tells you the dimensions of it. So it's a square that is 50 5.0 mm by 5.0 mm. And I know this might be a little difficult to read, but so if you look at this closer up, what happens is that it's got 4 pins on it, just like the RGB LED did. And it's kind of broken up like this, where this would be the R LED, this would be the G LED, and this would be the B LED. But instead of having a common cathode, which is a common ground, they have a common anode. So this would be plus, so these are 12 volts. And then this would be like the different grounds. So this would be like, this could be like R ground, this could be G ground, and this could be blue ground, right? So this kind of changes up the circuit for us because one, the Arduino can't really give you 12 volts. And two, the Arduino, while you can sync current into a digital pin, it's hard to like control when it's syncing. So what we do is something that's a little interesting. So we take this LED strip, right? So if we have, let's see, how do I want to draw this? So this is our strip coming in, and this is one of the LEDs on it. So let's say we have our 4 pins that come off of it. So we've got our plus 12, and then we've got R, G, and B. So what that means is that the 12 volts kind of goes all the way down the line, and then the like after the LED is done whatever it needs to do, it comes down through the RG and B channels to be grounded. So the problem is if I connect these directly to ground, right, what happens is all 12 volts go all the way up and all the way down, and you could burn out your lights, right? Or, well, your lights would be at full brightness. So when it's connected to ground, they're at full brightness. And then if it's not connected, they're at no brightness. So what we need to do is kind of modify the amount of current that makes it to ground. So something that allows us to control the current that flows through something is what's called an N-channel MOSFET. So it's got 3 pins. One would be the input, the other would be the output. So with an N-channel MOSFET, you typically connect the output to ground, and the input would get routed to one of our Rg or B pins, right? And then this middle pin is called our gate. So this gate would be what we connect to our Arduino. We have, let's say, this is pin 11 PWM, right? So what happens is, basically with these, is if I supply 0 volts to this, it, oh God. If I supply 0 volts to an N-channel MOSFET, it does not conduct. It conducts by default, yeah. Okay, so if I feed this to 0, right, the current goes all the way through. If I feed this 5 volts, it stops the current. So what that means is it's kind of like backwards from the LED we use today, where like a higher number equals more current. Let me double check. So now with PWM, what that means is if I send a PWM signal of 0, then it'll be at full brightness for red. If I send a PWM signal of 255, if I take like a time slice and I break it up into 255 segments, for 255 of those, it'll be off. So if I send it like 100, that means 100 of the 255 pieces of my time slice are going to be off. Yeah. The N-channel MOSFET?
Yeah. 8 high is like yes.
Okay, so I got that backwards. Sorry. When I send 0 volts to this, it doesn't let anything through, and when I send 5 volts, it does let something through. So what that would change to is like if I send a PWM value of 0, then I would get no light. If I send 255, I would get full brightness. And if I
have 0 at this, ground at the source,
but it runs in reverse. like it's confusing. But
Okay.
yeah, 125 would mean like half bright. So but it mentioned something important. The N-channel MOSFET. So it seems kind of weird, but this is the source pin on the right. This is the gate pin in the middle, and this is the drain on the left. And it's kind of weird to think that like the source is connected to ground when the current like goes to ground. But the way you have to think about it is that you're like supplying ground to the circuit. So yeah, does that make sense a little bit? So I actually built a LED strip controller my freshman year here at Tech, and like I hooked it up with 3 different potentiometers and some buttons, and I basically was able to power enough LED strips to actually like line the entire like roof or like the ceiling of my room with LED strips, and then like control it from my desk at my computer just by turning some knobs. So definitely, if you're interested in RGB LEDs, then it's a cool way to get your feet wet with LED strips, Arduinos. Cool. Does anybody else have any questions they'd like answered about Arduinos or lights or maybe even input stuff? Okay, so I'm not hearing any more questions. So if you guys don't have any, then we'll go ahead and finish off the meeting for today. So just as a last thing, we've got this slide up with all of the links and stuff. So if you guys want to fill out all of these links, yeah, you're welcome, Emmanuel. So yeah, just please go and get on the mailing list. Let us know what you're interested in learning about through the workshop or the interest form. And if that's all, we will see you guys next week.
Bye, everyone.
Bye.
Thanks for coming.